try to finish chapter 6 as soon as possible, and then we will probably have a little time and get on chapter 7, then we'll do the lab. Right? So chapter 6 about energies, so far we studied different ways to calculate the energy and different ways to measure the delta E or delta H. And right, so we know we can measure both of them. And if we measure the heat for a chemical reaction, when the chemical reaction is open to the air and the pressure is constant, and then we know that heat we measure is actually the delta H. So in addition to measure the delta H, and so we can also calculate, and that is like the purpose or the work of some of those chemists did, and they did a lot of those measurements, and they put in the table, and for some of those typical reactions, right? So then, in order to use their results, we need to review a few of those sort of relationship or the rule about delta H. So we just studying that like Tuesday, and we see we have 3 of those kind of rule or the relationship about delta H and chemical reaction equations, right? So the first relationship is if I give you the chemical reaction equation and I also give you a delta H, and those kind of chemical equation we call them thermochemical equation. Thermochemical equation, because in addition you see like you have your usual balanced equation, you will have the delta H. And the delta H gives you, that means for those coefficients as written. And so one relation is if you have this chemical equation and if you multiply the chemical equation by some numbers, in this example you multiply the equation, you multiply the first equation by 2. And you get this new equation. And this new equation will also have a delta H. And then this delta H will equals that older delta H multiplied by the same number you multiply for the equation. You multiply the equation by 2, and then the delta H you also multiply by 2. And obviously multiply and divide are very similar. So instead of multiply by 2 or divide by 2, you can see I multiply by 1/2. That means it's the same as you divide by 2. Right? And if you divide by 2 or multiply by 1/2, and you will do the same for the delta H, and you will get half of the delta H. Right? So this is a very, very important relationship. The second relationship is also important. All the 3 is very important for you to understand, this section. Which means if you like reverse the equation as written, what we mean by reverse equation is you will write the product as reactants and reactant as a product. So that is one step, and you can simply invert or reverse. So if you do that, you will keep the same number for the delta H, but switch the sign. So if you have a positive delta H initially, and then once you invert or once you reverse your delta H for the new equation will be negative, vice versa. And let's see, for this example, we say we have this initial equation CO2 on the right side of this arrow representing that separate the reactant with the products. And you can write, as I said before, you can reverse, so therefore I take the CO2 and the same number, same state, and everything the same, simply product become reactant become product. And delta H just simply switch the sign. If you initially have negative, then it become positive. You are going to do a lot of those chemical equation reverse, right? Both ways, reactants and products, and you reverse it, products become reactants. Very, very like common when you study the chemistry 1 and 2. Right. So this is the first 2 relationship, and then the number 3. has its own own points, and also has like the previous two relationship. That means in order to use this number 3, you have to think about what we just learned, that number 1 and number 2. Number 3 just tell you if you have some of the chemical equations in this picture, you have 3 equations. 3 can think about 3 reactions. We call them 1. We call them delta H1, that means for reaction 1, and delta H2 for reaction 2, and delta H3 for reaction 3. Right? So when you have those different number of chemical reaction equations, if somehow you can find out, in this example, you can think about reaction 1 plus reaction 2 give you reaction 3. And if that happens, then you will see the delta H will follow the similar addition equation. Right? So we said like reaction 1 plus reaction 2 equals reaction 3. So therefore delta H3 equals delta H1 plus delta H2. So to see this addition little clear, so let's think about equation 1. Do not change my I was still using the arrow. Right, so let's see equation 1. As I said, from this picture, it means A plus 2B produces C. Okay? So this is our reaction 1. Right? And every process, every chemical reaction has a delta H. Now this delta H, we call that delta H1. Because this is reaction 1. So you can well, reaction 1, reaction 2 doesn't matter. I just randomly number them. I number this is our reaction 1. So then reaction 2, I will call that reaction 2. That's very simple. It's from C. Let's see this red arrow. From C to 2D. So those are just different ways to tell you the chemical reaction equation. And this arrow means very similar as you have that equation arrow, left side, right side. And then this starting point, the reactant, and then the end of the arrow is the products. Right? So for reaction 2, you will see that C is our reactant and 2D is our products. Did you read that? Right. So then this you will call that delta H2. So you try to make another connection. Now let's say that reaction 3. Right? So reaction 3, just by look at this picture, reaction 3 has this delta H3. What I mean by the reaction 3 is you take this line, see this arrow, this dark the navy arrow, that is for reaction 3. And so therefore this beginning of this arrow is our reactant, and then the end is our product. So very easy. And so for reaction 3, it is A plus 2B produce 2D. Right. So those are different ways to to give you the information about the chemical reaction equations. I can give you like instead of this picture, I just give you those. So vice versa. If I give those, you can translate into this. Or if I give a picture like this, you can do that. Right. Now this Hess's law just tell you something like this. Okay. So if you take a let me just give them some name because just obviously this coincidence 1 plus 2 is 3. Okay. And reaction 1. So reaction 1 and plus I'll put that reaction 1 plus reaction 2. And let's say it equals what? I think some of you in your lab group, if you did that lab, I mean that alum lab, and you already practice adding equations, right? So that we made those alum from the aluminum can, that lab. I think some of you do the lab report, you already practice on adding the equations, right? adding equations, that means you will add the reactants with reactants, and then you add the product with the products. And then after you do that, you do two things. You can combine and cancel. Right? Right. So for these questions, it's relatively straightforward. So we are going to add in this. We are going to add in these two equations. Let me draw a line here. Right. So this arrow is that left side, for both of them the reactants, and right side both of them is the products. Right. So once you add, you will see you get A plus 2B, then plus C, the reaction from the second reaction. Right? Right. So then you will draw the arrow, and then you will get C from the first reaction, then plus 2D from the second reaction. So after you do those adding, and then you do two things as I tell you. You do like combine the same on the same side, and cancel out the same on different side. Sometimes obviously these two operations, these two things you do might contradict to each other. So either you cancel out them first or combine them first. You just figure out the best way. So probably cancel out them first, right? Then those left over you combine, because otherwise you combine, then later on you will cancel out again. Right. So let's say, according to what I just write, so you cancel out those same chemicals on different sides, okay? Then combine those leftover same on the same side. Okay? Now for this addition here, this is our result of adding reaction 1 with reaction 2. Get this. Okay? Now what we can do? What we can cancel out? Very good. So we can C and C cancel out. So then I think for this question that's it. We don't even have to bother to combine. We don't have any the same anymore. Right? All right. And so then what you left over is this reaction and these products. So what do you notice? What is this reaction? Yeah, so A plus let's say the A plus 2B produce 2D, and this reaction, you probably that's too simple. What is this equation in terms of that three reaction 1, 2, 3? It's the same as what? So we take 1 and then 1, right? Then plus 2, so that's 2. We get this, then we can out C. That's same as, you can see this A plus 2B, A plus 2B, right? And then arrow, and then produce only 2D, then only 2D. So that's the same as 3. Okay? So we pretty much just verify, so this is our 3. Okay? Right, so we get an answer. Okay? So this is not a question mark anymore. Okay? Reaction 1 plus reaction 2 is what? Sometimes the question is so simple, you feel like it. Because you could reaction 3, right? Because reaction 3. All right. So that is the first step of this Hess's law. Hess's law. Okay. If I give you like a few equations, okay, what you can do, you can just think about use all the other equations except 1. Okay. Then make some rearrangement, either multiply by some number, reverse them, and so on. So after you do that, you add them together, get the y, and then that means you will do the same for those delta H. Okay? So that's assuming we know the delta H for reaction 1 is this number, okay? And we also know the delta H for reaction 2 is this number. Understand? Okay? According to Hayes' law, because we already verified or we already proved, we already showed reaction 1 plus reaction 2 equals reaction 3. Okay? So therefore, reaction 3 has the delta H3. Right? Have delta H3. So this Hayes law just tell you, because we can get reaction 3 by adding reaction 1 with reaction 2. And then this Hayes law just tell you delta H3 it will equals delta H1 plus delta H2. Alright. Understand the Hayes law now? Okay. Now let's make it difficult. I think that's what we like, right? Make it more difficult. So in this example, I give you the reaction 1 and the reaction 2 already. Just for you to add them together, get the equation reaction 3. Right? Now make them difficult, that means I will give you some reaction, okay? And maybe give you 4 reaction like this. Okay? And so a little difficult than what I did in the last slide, because if you simply take these 3 equations adding together, you will not get that equation. What we did in the last slide, you did not do anything, just take reaction 1 plus reaction 2, get reaction 3. Okay? And then you will see reaction 3 is delta H. We call that delta H3 equals delta H1 plus delta H2. Right? So what you can do now, you already learned that last step. Okay? Now what you do, you are going to use that 2 other principles, what we just learned in today's class, do some change about these 3 equations. And once you do those change, you think that they are ready, and then you add them together, get the equation on the top. Right? Okay. Probably, if I only say that, it is not easy for you to understand. Okay? And right, I think one point you probably understand. Okay? The purpose is of this problem is use this 3H, 3 delta H. We have delta H here, even though the book did not give them some numbers, but just give you the equation with the delta H. The question, the purpose of this problem is, okay, is use this 3 delta H to get a delta H for that one. In the last problem, it's very straightforward because you take these 3 reactions together, adding together, you will get that equation on the top. Now this one you cannot get in that way. Okay? So what you do, you have to do some of those manipulation. Manipulation is either like a reverse or multiply. So these are the 2 operations of manipulation. Alright, so the 2 operations you think about to these 3 equations. Okay? And you do each one of these, okay? And to get maybe get, you don't have to always do that. If you don't have to do that, don't do that. Okay? The purpose of doing reverse or multiply by some numbers is get 3 new equations, and then you add in the 3 new equations and get that total equation.
can we decide if we're multiplying or reversing?
Very good question. Very good question. So as you think about how you are going to do that, you know right what you want to do, right? Either multiply or reverse. And what you do, you use that equation's chemicals as your guiding line. Okay? Obviously, you need those. Okay, for example, for this equation, you want to find out delta H for this equation. So let me emphasize that. Okay. So what is the delta H for this one? And this is our question mark. Okay. So what do? You will use those substance or chemical in this one as a guiding line. Okay. What we mean by that is I need a 3CS on the left side. Okay? And the only way we can get a 3CS on the left side is from some of those equations here. Okay? So I want you to see which equation will give you 3CS. Only the second one gives you CS, but the number is not right. Right? So therefore we multiply by 3. The location is okay, so you need this 3CS on the left side, and then equation 2 has a CS, is there CS, right, on the left side, so therefore you don't have to reverse. You don't have to reverse. But sometimes problem may be a little difficult because you will have like 2 equations give you the same substance. And then that will be a little difficult. Right? So this one is very simple. Right? Only equation 2 can give you, you think about it, only equation 2 can give you CFS. Right? And so therefore you just simply multiply the equation 1 by 3. If you do that, what you will do for the equation 1's delta H? If I call this is our equation 1. This is our 1, this is 2, this is 3, and this is 4. Understand? Okay. So we decide, because we need a 3CS on the left side, and writing 2 give us like a CS on the left side, but we need 3, so therefore we multiply that by 3. Right? What I did is the other thing first. Forget to change that. But anyhow, probably I will just write. So let's say our what you said, we multiply that equation 2 by 3, right? So if what that means, you will see you will have a 3CS and then plus 3O2 gas and then produce 3 CO2 gas. Right, so that's what we mean by multiply 2. They'll give them like those like that. Okay? Multiply 2 by 3, by number 3, not by writing 3. Okay? By 3. And what that means, you multiply everything by 3. And multiply every coefficient by 3. So initially the writing 2 has all the coefficients is 1, so therefore they all become 3. Right? Now what do you do to the delta H? If you multiply that equation 2 by 3, what will be our delta H? So this delta H become what now? Right? What do you do for the delta H? So this delta H so equals what? Anyone? And what do we should do to the delta H? Yeah, I think just you said multiply by 3, right? You make it positive or negative, that means depend on this, right? So because we did not do the reverse, so we just simply multiply that by 3. What you get is negative 1180.5. And all those, let's say I just write the unit on top, all those are kilojoules. Right? Okay, see. Any questions? Right. So then this is what we did to reaction 2. Okay? And what reaction you do first doesn't matter, okay? Because you just you have to use those as a guiding line. Okay?
15.
Understand? Now the second reactants, what I did here is do one by one. So I want to use this as guiding line, so I just want to say I need 3 carbon. So therefore I multiply that by 3. Now the second one will be our H2, H2 gas. Let's see which equation has the H2 gas. Number 3, right? Number 3, third one. Only the third one. Anything else? And any other equations? Besides that one, that one need the H2. Besides this, that one, let's see. Only the number 3 gives us H2, right? And the H2 should be on which side? On the left side of the arrow or on the right side of the arrow? On the left side, right? And this equation 3 is on the left side. What do you think we should do to get the same side and same number? How many H2 do we need? 4. And how many H2 the equation 3 gives us? 2. So therefore, what do we do? Alright, so we'll do like multiply 3 by 2. By number 2 again, okay? Alright, so what you do, you will see you're gonna get a 4H2 gas plus 2O2 gas and produce a 4H2O gas. And then this equation will have a new delta H. Right? So all those delta H, I did not give them some number, I just call them delta H, but you know now if this delta H follows this equation, that means it's for that, and this is for this. Alright? So what will be our delta H now? Okay, which one by 2? You know that, right? So you get negative 967.2. Alright. Jonathan, how did I get this number? So I get this delta H, negative 967.2. How did I get that number?
Because you would multiply the 1 by 2.
You multiply that number by 2. So why we multiply that number by 2?
Because there's 2 in the original and then 4 at the bottom.
Yeah, because we multiply that by 2. We multiply the equation by 2. Okay? We multiply the equation by 2, you will multiply the delta H by 2. Okay? Again, another question. Why you multiply that equation by 2? To get this 4H2.
There's 4H2 in the reaction.
Very good, Andrew. We need a 4H2 as a reactant. So after we multiply this reaction by 2, and you will get exactly 4H2, and that kind of gets ready for our reaction. Alright. So this question is kind of easy. But that's a very good starting point. Okay? So I choose this because I can like just take 1 by 1 as a guiding line. Okay? So then the next one you need this propane C3H8 gas, right? So which equation will give you this guy? Only the first one? Are there anyone else? So sometimes maybe 2 equations give you the same, but in this one just again just the first one, right? Now this equation is the one you want to find out delta H. You need C3H8 as what? As a product or as reactant? As a product, or on the right side of this arrow, right? Now equation reaction 1 give you this C3H8 gas, right? And but that is on what side, Brad? That's reactant. Okay? Now what do you do? Yeah, very good. So you can just reverse 1. Reverse 1. So reverse 1. That means you don't do anything. Just you don't multiply. You still do something. That's why that's what you meant, right? 4H2 gas, and then you will have that C3H8G plus 5O2G. Understand? Now this one will have a delta H, and now tell me what will be this delta H?
3 times.
What will be this delta H? Just the sign, right? So therefore, what will be the number? What number? What will be the delta H? With a positive 2043. Any questions? Good. Right. Now we think about I use this equation. We want to find out delta H as a guiding line. Okay. Now we pretty much getting all the three chemicals that in this equation kind of like in the right place with the right number. Right. But you still want to like verify. Just do a check. How you check that? Okay. Either by doing this. Okay, let me change the color of the pen. So if I draw this line here, right, and this will be the line that will separate our reactants and products for all the three new equations we want to add. Right? Right. So after you draw the line, you pretty much just think about the two words I tell you. Probably try to cancel first and then combine. Alright, so let's do the cancel out first. So what cancel out with what? Anybody tell me what can cancel out? Let me give you starting point. This 3CO2 gas on the right side. You find another like a 3CO2 on the left side. Yeah, right here at the bottom. See that? So even though we did not have really like collecting them together and just put like one arrow, but we understand that all those will be on the left side, right? Right. So this comes out. Right. Okay, now your turn. What else comes out? Huh? H2O, very good. 4H2O. Here, I get 4H2O. Where's the other 4H2O? Fine. See, that's very good. So then these four, right? One on the left side, one on the right side, that comes out. Okay, the next one is a little difficult. Okay? Oxygen at O2. Okay, how many O2 on the right? Yeah, everyone see that? 5 O2 here, right? So that's gas, all of them are gas. 5 there, right? And probably now you can combine and cancel, but that's single order route. So you want to cancel all these 5, you also need a 5 on the left side. Do we have altogether 5 O2 on the left side?
Yeah.
Samantha, where do you get the 5 O2 on the left side?
The first one, 3O2 and.
So here you have 3 here, right? Where else can I find 2? 2 here, right? All right. Right. So that's it. So that's it. I think we count out everything we want to count out, and now that become very clear. What is left over on the right side? What is left over on the right side? Let me change back to the red pen so I can circle those and see. This is the only one that left over. What else left over on the left side? This one, right? This one comes out. What else? This one. 42. I mean 42. Alright, so then that's exactly matching the one that 4. Right? So when I circle in red, right? So 3 carbon, okay, and 4 H2, and then 1 C3H8. So now what do we do? What do we can get this delta H? This delta H should equal to what? What what do we will do about the delta H? Delta H will equal to what?
You said because the.
And now tell me, so delta H, let's call that delta H in our delta H reaction. So delta H reaction. So delta H reaction, and again, by now E plus 1 plus 1 plus 1, not maybe not literally plus. That tells me that those numbers.
Negative 1,000.
Negative 1,100, 80.5.
And minus 90.
Okay, you can see plus,
7.2.
then negative 967.2, right?
Plus 2,043.
Very good. Then plus 2,043. Okay. Anyone to understand? All right. So you adding these three numbers, and you put these three numbers together, and you get the result, right? Negative 1180.5 minus 967.2, that's plus 2043. I get a 104.7. So negative 104. So be careful with those guys. They were negative 104.7, and the units, all those are kilojoules, right? So therefore it's kilojoules. Okay, any questions? It's kind of interesting process. Kind of, I think it's kind of like a very good mind thing. Intellectual activities. So I didn't even do some funny there. Alright, let's do a practice. What do you think that you should do? You get a C? Okay, what do you do to get a C? What do you do to these two equations?
We see that the reaction is reversed, so this equation has to be reversed to on the left side.
You need a,
And multiply both equations by 2 to cancel out.
yeah.
So then you multiply those with both equations by 2 and the symbol is reversed.
Yeah, then adding them together. I think that seems that's the approach. I don't know the number. Pretty much 90.3. Yeah. Negative 103.4. Right? Any questions? How did I get negative 103.4?
What was the answer?
Well, we reverse it. C.
C? Okay, good.
Alright, I think this one, you get it? You know like what we did?
Negative T?
Right? We reverse both of them. Not only that, we also multiply both of them by 2. Right. Okay, so why I reverse both of them? Let's see why I reverse why I reverse the first one. So you use those as a guiding line. In the example I tell you, you go one by one. Okay? You can still do that. If you do that, you will see you need this one. What is this one? This is NOCl, right? You need NOCl. You need how many NOCl? 2. Which equation give you NOCl? I give you how many? So therefore, is not the right number, also not the right place, right? You need on the left side, and you need 2, right? So this guy tell you, you reverse. So this 1, this 2, you reverse 2, and also multiply 2 by 2. Right, now let's do one thing first. Let's do the reverse first. If I do the reverse, so I will get NOCl gas produce NO gas plus half Cl2 gas. This is simply the reverse, right? But we said we also have to multiply that by 2, right? Now if you simply reverse this, so this delta H will equal to what? Positive 38.6, right? Now we said we have to also multiply this by 2. And now let's multiply, so we'll get 2 NOCl gas plus 2 NO gas, then plus Cl2 gas, because 1/2 times 2 is 1, right? Now this delta H will equal to what? This delta H will equal to what? 77.2. We don't have a calculator, right? How I get 77.2? How did I get 77.2? Multiply what by 2? Multiply this 38.6 by 2. Why I multiply that by 2? Because I multiply the equation by 2.
Okay, we're for 17.
Alright, so let me now erase some of those, and we will keep that last result. Okay? And let's think about what should we do about the first equation. What should we do about the first equation? So let's use this as a guiding line, right? We already kind of narrowed down this guy. We need this 2 rectangles. We get these 2 rectangles now, right? We got that 2 rectangles now. So what else do we need? We need also the products, right? We need 1 N2, 1 O2, right? And 1 Cl2, right? I think some of them we already get it. Do we have the Cl2? We have the Cl2 here from this one. What else do we need is 1 N2 and 1 O2. But which equation will give us 1 N2 and O2? The first one. But the first one, that gives us N2 and O2, 2 things wrong. One is not in the right place. We need N2 and O2 in this one on the right side, that is on the left side. Okay? So if that happens, you first think about the reverse then. Okay? So let's do that. And so we'll do the same. Reverse 1. Okay? Now that's reverse 1. So we'll have NO gas and half N2 gas, and then plus half O2 gas. And now this delta H will become what? Very good. That's negative 90.3. Okay? And we did not do anything else yet. We just simply reverse. If you simply reverse the equation, and then you just change the sign. So if you have initially positive, so that becomes negative. Right? And as I said, if you reverse this, okay, that's good. You get like N2 and N2 and O2 and O2 on the right, and at the right place, so right on the right side. But what is wrong now? As I said at the beginning, we have 2 things wrong. What are we wrong now, then? What is wrong? What is still kind of wrong for this equation? Only half. Only half. So what do? You multiply this equation by 2. Right? So let's see where. Multiply by 2. Okay? Now watch carefully. I'm going to multiply this by 2. Okay? So this angle become 2 angle. Understand? Okay. Now this is half n2 will become what? Become 1 n2. Now this half O2 will become what? Become 1 O2. Now what will happen to our delta H? You multiply by 2, right? Very good, Judy. So therefore we get negative 180.6. Right? And you simply take like 90.3, right? And multiply by 2. Negative 90.3 and multiply by 2. Alright. So you kind of get them ready, but always do a check. What you do now, let me just probably do that. Can I erase this one now? You don't need this one now, right? I want to erase that. Okay? And so we'll have these two new equations and these two new equations. So preliminary, we're assuming these two equations adding together. Okay? So if we add these two new ones, we will get this. Right? And add these two new ones. Usually, chemists says like to give them some names. So we can call this is our, this come from 2. So you call it 2 prime. And this come from 1. Call them 1 prime. Okay? So what you do, you will add 1 prime and 2 prime. See if you can get this guy. Okay? So as what we did before, you just draw an arrow here. Okay? Draw an arrow here. And left side, for both left sides, it will be our right hand. Even though sometimes it might come out, but right now just think about all those on the left side, it will be our right hand, all those on the right side will be our products. Alright. Right? So that's it's kind of very interesting practice. Right? So after you get this equation kind of ready, okay, by using this as a guiding line, you see I get everything. I get the right hand. I know where the product will come from, where the right hand come from. You see that these are the two equations that will give you that, right? And you check that. So what you do, just as I said, that two words cancel and combine, right? So what can come out? 2 angle on the left side, right? Yeah, so my pen never off. I pointed to that part, but come to that way. Right? And there's 2 angles on the left side, right? And come out angle on the right side. Right? Where the angle on the right side? 2 angles on the right side. You see that? You see that? On this one? Alright? I think that's the only one I can come out. So this is gone. This is gone. Alright? So after this 2 is gone, then we will not have time to go to the first example. Oh, I give you a clue for it. Alright, now what left over, right? So left over is only 2 angle CL gas. You agree? That's the only one that's left over on the left side of this line. You agree? So then that will be nice. What have left over on the right side? we have N2, even though I draw the line little like into that, but that means we can cut out the N2. And then what else have level over is O2. What else we have level over? CO2 gas. Right. See, you like you show or you prove, you add in these two new ones, two new ones that come from that two or one, and adding them together get this one in highlight, right? Now this one you want to find out delta H. So therefore delta H will simply equals the combination of this, because that one, the one in highlight, is kind of combination of these two. Right? So you can write so delta H over this delta H, so no question, that will equals -1 80.6 plus 77.2. And let's give you -103.4. Okay, any questions? Right. Try this one. So what do you do? Anyone find some answers? Keep working on it. What you do is using those equations, so that is in the highlight in yellow. At the guiding lines, you need CH4 on the left side. Any idea? I think probably it's a good idea to practice right away, right? Yeah, to practice right away. To think about you need CH4 on the left side. So which equation give you CH4? Which? The first one. But is that in the right place?
No.
Oh, so you reverse the first one. Very good, Julie. And you probably don't want to use Cl2 as the guiding line. That's sometimes difficult. Why that? Because Cl2 that comes from two equations. So jumping over that one first. Think about where can you get CCl4? Which one gives you CCl4? The second one. Is that in the right place? Right number? I think that's the right number. How many CCl4 do you need? Just one. CCl for the right number, okay? So therefore you probably, what we said, reverse the first one, right? And keep the second one as it is, don't do anything to the second one.
The answer is A, right?
Answer is A. What do you do to the set, to C? What do you do to the equation 3, variance 3?
For CCl4, you don't do anything to it. It's already in the right place, it's already in one.
You also, let's see, the next one is HCl, right?
Yeah, for HCl is in the same place, you just gotta multiply by 2.
Very good. So when you do that, you did not really narrow down that 4Cl2, right?
Right.
But if you think about it, if you did not do anything to the second equation, the second equation give you 2Cl2 on the left side, right? And the equation 3 give you also 1Cl2 on the left side, but after you multiply by 2, you get also 2Cl2. Better is just try. It's kind of tedious if you try and write them down, and that take a long time. Okay? I know that most of us will try to don't bother to write them, just think about them in mind. But if you just think about them in your mind, sometimes you get too much thinking, you get confused. Okay, so what I said is we call them ABC. Okay, so this is delta H, we don't know. What we said in the reverse A. Reverse A, you will get a CH4 gas and produce carbon solid plus 2H2 gas. And then since those delta H, I just put them on the top. This will become 74.6, positive 74.6. So agree? So as I said, we'll keep B as it is. And you will see that we have 1 CS plus 2 Cl2 and CCl4 gas. If we did not do anything to this, you still get negative 95.7. But now the question is why you do that? Why you just reverse the first one but do not do anything to the second one? You need to reverse A because you need this guy, CH4, right? And that's CH4 on the left side, but this one on the right side. Right? And that's the only one that gives you CH4. Now, why you don't do anything to B? Well, B, as I said, you jump over that one first. Okay? You will look at this one first. You need a C. It's kind of very tedious. CCl4, CH4, and HCl, right? So what you need for this from the second equation for equation B is this guy. Say C and CL4. Right?
Why don't you say we need CL2?
CL2, why I skip that? Very important. Why I skip that? Because this B gives you CL2, and then this C also gives you CL2. So if that happens, you better skip them first, because if you do that to one, what you do to the other one will influence you. Right? If you just say, okay, I need a 4, so I multiply that by 2, then what do you do to that? You have again another one, right? So when you have those two equations, you do the same one, you just skip that one first. It's a chess game. So what do you do? What is that you see? Multiply C by 2. Don't do reverse, just multiply that by 2. Right, so what you do, you will get 2H2 gas plus 2Cl2 gas and produce 4HCl gas. So if you do that, and your delta H will become negative 184.6. Where did I get this negative 184.6?
You multiply negative 6.3 by 2.
Then why I multiply that by 2 get this?
Because what you do to the reactant, you have to also do the delta H.
Yeah, I did that for the reaction. So I get this equation from that, not simply from that, but multiply that by 2. Okay? So I did not do the reverse. So I have initially I have 1H2, so therefore become 2H2. And I have 1Cl2, become 2Cl2. Understand? So I have a 2HCl that become 4HCl. Now the question is, why you do that? Why you multiply that by 2 to get a 4HCl? You understand my question? Why you multiply that equation by 2, Samantha, to get this 4HCl?
You multiply all both sides.
Because we need this 4HCl. So you see, we skip that one, but so right now we kind of narrow down this one. We have that, right? By reverse this one. So this one on the right side, we reverse to get on the left side. Alright, very good. So you need a 4HCl, and only this C gives you 2HCl. That's not the right number, so you need a 4. So therefore you multiply that by 2. And then you will get multiply this by 2. Right? So what do we do now? We get there new, this is not new, we get, if you do the chain, you get new those delta H. What do you do now? Let me draw the line again, see if you can, you have to show that. You have to show that your result is right. Right? So where I draw the line like this, so this was the line. Okay? So pretty much follow the arrow. Okay? So those on the left side and on the right side, if they're on different sides are the same, count them out. If they're on the same side are the same, combine them. Right, so what comes out? Anyone like notice some of those come out?
C.
The C.
2CL2.
What else comes out?
2CL.
You mean 82, right? 82. So these two come out together. Okay. Now let me just use different examples. So this is for the 82, right? And this is for the 82 here, right? So we have 282. Let's pull it out. Okay, now that's right. Now what you do? You see this Cl2 here, and now let me just change the color. See here, Cl2 here, you have 2, and you have 2. Do you cancel them out or you combine? Combine, they're on the same side, combine them. Okay? Remember that 2 I tell you? You cancel out the same on 2 sides. If they're on the same side, combine. Very similar as algebra. Alright, I think that's it. Right? So what left over now, from this one, you have that. Okay? And that becomes that. Right? Understand? Right? Okay. So where will be this, now down, where will be this 4Cl2 come from?
The 2Cl2 in equation 2 there, and
Oh,
then
this
in
one?
3, the other 2Cl2.
From this one?
Yeah.
Right. So that's finished. I think that's all the rectangles on all those, right? So this 2 is gone, that is gone. What left over is this one, then follow this. And that's it. So we wouldn't need that 2 rectangles. Well, what about the product? You have to also check the product is right. Product, any product left over from that one, or gone. That comes out. Any product left over from this one. Yeah, so this one is the CCl4, right? So let's draw a line here, so this goes there. And then that would gone on that, right? What is our product from the last one? 4HCl. Do we need a 4HCl? Yeah. All right. So once you identify, all of them, you go to the right place, and then there's nothing left over, right? Even so there is not a left ruler. If it's your left ruler, that means you're gonna count them out, right? Alright, so now once you verify that, your delta H will work in these three numbers. Understand? So your delta H, so adding that together, so your delta H, if I call that delta H, that's delta H rating, right? Adding here, so this will be our delta H rating here, right? It will equals 74.6 minus 95.7. And then what else? What do you say there? Negative, then what? 184.6. Right? Yeah, I think you put this, you combine all these three numbers together, okay? And that will give us, so this will equals negative 205.7, right? Understand, right? So therefore the answer is A. Right? Good. Right. It's see, I feel like so much get into it, okay? It's not the last one is A. What about this one? D? Tell me what you did. What you did? What you did?
I reversed the first equation,
The first, do what to the first one?
I reversed it,
Reverse it.
and then I multiplied it by 3 halves.
Very good, very good. Very good. So let's do that. Let's do that again. I think you guys kind of right. Okay. So let's call them. So this will be our 1, 2, and 3. Right? Very good. Maybe like you do that. So I'll come here and do it on the board. Okay, so you come here to on the board, on that side, okay, you can explain that. Everyone practice. I think you get all the D. So you reverse the first one. Not only you reverse the first one, you have to also multiply that by -1. Because you need to multiply by 3/2. Because you need 3 A and 2.
I just multiplied that one by 3 and that one by 2 and I just divided my answer.
Oh yeah, you can do that. Yeah, you can do that. You can do that. You do that. You add them together. You get twice of that equation in yellow. And
I
then
figured that's what I had to do because that increased to get a 3.
yeah.
What was the answer for this?
I'm gonna say the D.
That's 65.
Okay, so we'll do that later. Yeah. Okay, so you understand this session, right?
Yeah.
Just pretty much get those equations ready, and add them together. You just get the equation you want. Very easy. Okay, that's good. Keep practice. So practice before the class and practice after the class. You did okay, seems on the first exam, right? And for the first few chapters, the same for this next exam. Anyone need help?
Like next week is it then?
No, the week before Thanksgiving. In a few weeks.
So, yeah,
2 weeks?
no,
3 weeks?
1 next.
3 weeks? Perfect.
We still have 2 more chapters, right?
Yeah, we have chapter 7, chapter 8.
Maybe it's just bothered me now.
Can you fill that in? Okay, don't put it back up there. Throw it away.
You use,
I didn't realize until later.
It used to be there was something we did.
Where are you, maybe?
Yields, rehabs, plus
okay, so what do? Sorry, did you get a D?
This is just where
You need to do 2 things for the first one. Okay? You see the first one? So the first one you have that angle 2, and that's the only one that has angle 2. You need the angle 2, right? But that's right now this is the arrow here, that's on the right side. In the equation you have, it's on the left side. That's one problem. So what you do, you have to flip that one. You have to practice. You have to like practice and you get D.
Oh, so you just have to in terms of delta T first. Before you confuse.
How we doing?
I was the best. Oh, yeah.
Okay, Brian, you finish? Okay, so everyone listen to Brian see what he did.
So for the first equation, I just reversed it and times it by 3 halves. That gave you what you needed on both sides. For the second one, all I had to do was multiply it by 1/2. And for the third one, you just reverse it.
Exactly.
And what happens is you get, for O2, 3 halves minus 5 halves, which is -1 on this side, and then there's 1 on this side, so those cancel out. The N2s cancel out then, and the N2s or the NOs cancel out here, but only 2 of them cancel out here, which gives you the 1 that you need for the final equation. Because you reverse the first equation, that becomes a positive, and then you times it by 3 halves. The second one, you just divide by 2, and for the third one, you just change the sign. And when you add all 3 of these together, you should get the.
So the second one, you just multiply by half.
Yes, just by half. You don't reverse the rest.
Don't reverse the second one.
You did it.
Did not.
Because the first thing that I do when I'm doing these problems is get everything on what side it needs to be on for the final equation to work out, and then I start multiplying.
Any questions? Any other questions?
So the third one, you just,
Reverse it.
Just reverse it.
Yeah, I know that you not like those universities or you like living together on campus. It's not easy to form a study group. I still try to form a study group because weekend everyone has free time and you can come together, maybe go to Starbucks or McDonald's and sit and study. Right? But if you talk to each other is little easier. You have the same language. And also making my work a little easier.
Anyway.
Well, any questions? I think that's good. You study other questions. You're always curious. Right? So what he did, summarize if you miss something, watch the video. Understand? Right. Now, as I said, you can use those kind of idea to calculate the delta H for some reaction you don't know. Right? So really, a lot of those chemists are spending a lot of time and measure those delta H for some reactions. What they measure not randomly measure. So they measure some of those delta H, the so-called formation entropy. Okay? And also I can add a special condition. So that special condition, we call them a standard state. So don't be confused by what we studied in Chapter 5 called the STP. The STP is only like two variables, standard temperature and pressure. Okay? Now standard state, there's more like specifications. Okay? So that means for the pure gas, it has to be like 1 atm. And usually you also have some solid or liquid in the chemical reactions. And that means you have to have those pure solid or pure liquid. Those kind of conditions called the state, really a hypothetical condition, and obviously if you have a pure gas and pure solid, pure liquid, they will never go to chemical reactions. You have to mix them to have chemical reactions. Right? But we use those as an approximation. So that about that. Sorry. The temperature usually just not really in the specification. You can use any temperature to do like those. But when we measure this, they measure at 25 degrees Celsius. And then some of those like substance not in pure states, they are in like pure solution, you show their concentration 1 molar. Alright. So then once you specify those conditions, and your chemical reaction still have the delta H. Understand? And then your delta H will have this new notation. We call them delta H naught. And that 0 means nothing. Right. So that's not usual. So you still have those delta H like red light here. Right? But if those chemical reaction happen under those conditions, you will give that delta H a special notation and put a head, a knot on that. So then we are going to see like also like some of those special reactions. Okay? Those special reactions, we call them formation reactions. And those formation reactions also under those conditions, those conditions means standard state, pure gas, pure liquid, 1 atm for pure gas, in a solution 1 molar. Again, that's hypothetical. That's impossible for have a chemical reaction. Right? But once you have that in mind, and you can think about how you produce some of those substances. For example, how you produce carbon dioxide on this slide, next slide, from that element. And then, so then you will have those numbers and measure hours in the table. Right? And I think this is only one part of the table. In the book appendix C or E, there's more numbers. If you go to the chemistry lab, there's a physical chemistry handbook, there's more numbers. So for most of the common, like those substances, substances either compound or element, right? And they will have those, this number in it. This number again called so this title means standard enthalpy formation, right? And if you see this word, this equals delta H naught F. Right? You already see this delta H many times. Delta H means the enthalpy change in a process. Right? Now this delta H naught and F, each symbol, each something in the notation tell you something. Right? So this naught tell you is those standard state. Right? And then this F means formation. Right? Now let's talk about how you write a formation reaction equation. And then you can associate this delta H with those reactions. Alright, you already know how to write a chemical reaction equation in general. You will see the chemical reaction equation has left side and right side. So you have those formation reactions. Right. So to make a formation reaction, make sure you know what substance you are writing for. You want a formation means form. You want to form what? For example, you want to form CO2. So then this CO2 will be your only products. And you just think about how you produce CO2 by CO2 itself. What state you also specify. Right? And then you think about those reactants. Reactants is also similar. Reactants, according to what we said here, is from those elements in their standard state. Right. So you need to identify. You want to produce CO2. That means you need carbon, and you need oxygen. So you first identify you need these two types of elements, and then you just identify what is their standard state, or what is their stable state. So what do you use? Do you use carbon, or like graphite, or use diamond, or you use some of those new carbon, those like nanotubes or something, right? Oxygen, what do you use? Do you use like oxygen atom? Do you use oxygen O2 or ozone? Right? So if you don't know, you just go to that table and find out which one has delta H0F equals 0. So whatever the format for that element, give you this number equals 0, use that. Right? So for carbon, obviously you want to use solid carbon, not gas carbon, not like liquid carbon. And then solid carbon have different formats. There's like diamond is a solid carbon, and graphite. So I will write graphite. Because if I go back to the table and I was assuming for that, you see here carbon. I think we have carbon here. Where is carbon? Carbon here. See carbon, solid, graphite equals 0. So you just choose the element that has those kind of numbers equals 0. So therefore, you tell me which kind of format shall we use for the oxygen? Oxygen is here. If you can see the O2, not O3, not H2Cl, right? See here, O2 gas is what? 0. Right. So that's like you identify what element you use. So you identify what format of element you use. So therefore we kind of very quick. I think of that. Right? Okay, what else we need? We need oxygen, right? How do you know you need oxygen? That's a silly question. Because you have oxygen in it. Right? Yeah. So that oxygen, you already know, it's not O3, not O1, it's O2 gas. So step by step, you first write your product. You only want to produce one more, so therefore I did not put 2, 3, I just put 1 here. Then you identify you need carbon, you need oxygen. So you then go to the table and say carbon should be solid graphite, oxygen should be O2 gas. And that's it for the what you need. Now you just balance those equations by using any number. But don't change this number, always keep this number 1. Right? Yeah. So for this number, we don't have to do anything. Right? So the equation is balanced, and you identify the reactant, you get the products. The product comes from the question. Understand? Now this chemical reaction will have a delta H. Any chemical reaction has a delta H. Do you agree? Now this delta H, you are going to give that a special name. Because this chemical reaction is for the formation. So therefore, for the formation of CO2, so that we get that F. F means the formation. Okay? If I tell you this reaction is happening like under those standard state. So here a gas, and there's a pure solid and gas -m, and you use that special notation like not. So then you probably also like bother a little bit. You have a little more details. So you want to say this delta H for what? So I will write down here. Okay. So delta H0F. So I want to write more details. I will say this is for CO2. For CO2 in what state? Gas state. And then I will finish this notation like that. So you're adding little by little. So what that means is this number is still a delta H. But just more details, delta H what for what and so on. Not really that difficult. Understand? Alright, so I think we should be able to know that. So if you want to write a formation reaction for CO, not CO2, right? So just draw arrow. What will be your product? CO. And what state?
Yes.
Yes. Okay, now what element do we need? We need a carbon, and we need arsenic. Repeat what we did. What kind of form we can use for carbon? Solid. And I will just write graphite. You don't want to use diamond. Diamond is not the most stable element. Okay? And then plus O. Oxygen, what form you use? You use O3 or O2? O2. So if you don't know, just say like what give you 0. Okay? So those delta H0F equals 0. Okay? Use those elements. But for this problem, you have to do like one more step. You want to balance the equation. You don't change this number here. You don't change this into 2. That's not how usually. I mean, usually you want to do that. Okay. Now here you don't change this number. Never change this number. You keep that always at 1. Why that? Because you are writing this. Understand? Right. So therefore, if you keep this at 1, and what you can do to balance the carbon O? Is the carbon balance?
Yes.
Yes. And then how can you balance O?
Multiply by 1/2.
Yeah. So that's all one problem. So carbon practice. If I want you to write this guy. So what will be our product? Will be Mg, CO3, solid. Yeah, that's it. So what element do we need? Obviously we need magnesium. What else? Carbon. What else? Oxygen. So simple. So then you see magnesium, so what should you use? Should you use Mg2, Mg3? You go to table, you will see just simply Mg solid. So therefore, that is good. Right? Carbon solid many times, so this will be the graphite plus O2 gas. That's it. Okay? Balance equation now. Don't change anything here. Okay? Do not change that. And keep that as 1. Okay? Mg balance, carbon balance. What do you do to this O2? That's not good. I put it behind, but you should put it in the front, right? Alright, so that's it. Alright? Alright, so let's do another one. So you want to get that for this C6H12O6S. So what do we use? Carbon A. What else we use? H, very good, H2. So you will find out H2 gas is the one that has delta H0. Okay? and oxygen for the O2 gas. Understand? Alright, so then this repeating, this is the graphite, and then plus H2, then plus O2, that's also repeating. And now let's see, your balance equation, how many carbon do we need? 6. Don't change this number, right? So this number always 1. And then how many H do we need? We need, so therefore we need to put 6 here. And then this one will be what? Yeah, that's good. Right. So then for both reaction, and for both of them you have a delta H. And this will have a delta H. Those delta H you call them what? Delta HF. Delta HF. Right? Yeah. So the book could give you some of those numbers. You can get the numbers too. You can just if I tell you want to find out this delta HF0 for this guy, and you can go to the maybe like in our book we don't have those numbers. You can just use some of those handbook and get those numbers. What's the answer for this? Down here the E. That's very straightforward. Right? The answer is E. E. Right. So then we can use those delta HF0 to the calculations. Just very simple setting, one formula. Right? So I will usually give you the data for the delta H, and I just remember I saw like you already did some practice. Okay? So if you have this number for all those chemicals you need, what you do, you want to find out those delta H reaction. Right? You just take this number for the product, multiply by the coefficient, and put them together, and then subtracting by all the number for the reactant, put them together. Right. For example, for this one, so what you do, you will find out the delta H0 reaction. So this is like different than what we saw before. Right? What we saw before, I just see like find out delta H reaction, not those not. You have that not because so those guys. So this delta HF is from the knot. Right? So according to the formula, so this will equals 4 times the delta HF of that angle gas. You know this notation, what is standing for. Right? Then plus 6 delta HF knot added for H2O gas. Right? So right now I just writing those notation out, really don't have the number. Right? Then subtracting. 4 times delta HF for that NH3 gas. And then subtracting 5 times delta HF for that O2 gas. Then if I give you those numbers, just substitute into the equations. Okay? Now here what I did is subtracting. It's the same as you subtracting this together called the plus. Alright, so then where everything is straightforward, but just be careful sometimes I might, the book or those exam question might trick you a little bit. So I will give you every numbers. I will give you every of those delta H except this one. You should be able to tell me what will be the number for this one, for the O2 gas. Anyone know the number for this delta H, for the delta HF 0 O2 gas? What will be that number? 0. So even though sometimes, for some of those stable element at a standard condition, 0 is not give to you. Right? And then just when you do substitute those numbers, make sure you're tracking what number for what, don't forget the coefficient. If you will ever forget that. Understand? Alright, so let's do a practice, see if you can get that.
Is it A?
Is it A? Yeah, how do you get A?
I mean, I just did math for the most part. I just did 1675 minus 824.
You said you want to calculate this number, right?
Mm-hmm.
According to the formula, it will equal to what? Delta H0F for what? For the product,
Product minus reactant.
and then the coefficient, right? The coefficient here, let's say if I write AL203, I try to hurry up. Now what will be the coefficient for this number? Coefficient. Coefficient here is 1, so therefore 1 here. So then plus 2 times delta E0F for the R solid. You understand why that? Right? So that's also the product. So those are all the products, so then you just subtracting what? 2 times delta H0F for the AL solid, then minus the delta H0F for the Fe2O3 solid, and this also 1 here. Any questions? Ask me. If you don't accumulate it, if you see that one number, you don't know like where it come from. So then we don't have the number for this guy. We don't have a number for this guy. That means they are what? 0. That's 0. Okay? And just substitute this number here to here, and this number here to here, and you will get 8. Good. So that's good. So that's, and I think that's the last one, right?
No, there's
No,
one more.
there's one more.
You have to find the Q.
This one, right? This is good. So you want to do like power things. You first want to find out what is your, so this equation is given, this is your chemical reaction equation, and you know what is the product with reactants, very straightforward, right? Right, so delta H0 reaction is equal to what? Product minus reaction, right? So only one product, we have 2 of them. So don't forget you have 2 times delta H0F for what like substance? Fe2O3, what state? S. And then minus 4 times delta H0F for the Fe solid, minus 3 times delta H0F for O2 gas, right? But here I only give you one number, give you this number for this guy, right? So according to the equation, everything together you should have twice of that, and 4 times that, and 3 times O2. But I don't have the number for Fe solid and O2. And what are the numbers? 0. Okay? So therefore 0 here, 0 here, you take 2 times this number, right? And you will get something negative, so I think the answer is either A or C, right? Right. So then the final answer is C, right? And that answer you need to do like one more calculation, like use those what you learned in the first section, right? Alright, I think that's it. So we did not.
What do you solve for Q?
Huh?
What do you solve for Q? Like the second part?
How you
Wants to know
solve?
the heat produced.
Okay, so that's it. We have
Do some conversion factor?
yeah, that's what we here done. We have 4 Fe solid plus 2 O2 gas minus 2 Fe2O3s. And this one has delta H equals negative 1.48/4. Right? So once you have this number, and you can pair this number with any of those 3 guys. Okay? Understand? Well, hold on, that's okay. So you know how to get this number, right? You know how to get this number.
Yeah.
So once you have this number, you can add them together. That means you will get equation. You will get 4 more Fe over negative 16 for 48/4 kilojoules, or negative 16 for 8/4 kilojoules over 4 more of Fe.
Oh, that stupid equation, okay.
Yeah, I always use it that way. The answer is C. Well, you will find out. You will start with like 30.0 Fe. First convert this into moles. I think that's 55 something gram over 1 mole. Then you multiply by this guy. Right? So check that. I think that's what we are. Yeah, it is. Yeah, give me the CRE for the. No, you need the we don't use for Chapter-7.
Oh, okay.
We'll start on once we start on Chapter-7, 71. We'll start on 71. Yeah, everyone will have a break.
Oh.
What, those guys we brought? Yeah. Just for here.
Very small. Wait, did you know what you're doing?
No.
Carson, here's your schedule for the chapter 7. So we don't, let's start on chapter 7. Okay, we'll start on 71.